we're going to move on to cost curves. We're going to draw the same graph over and over and over, which on the one hand is bad because it's kind of an ugly graph. On the other hand, it's pretty refreshing because it's going to be the same thing over and over and over. We're going to always use it for the stuff that we do. So I want to slowly introduce that. Do you need to make a comment? This is a couple days later, you're watching this, but I'm making this video the same day. That's why I'm wearing the same shirt. I don't want you to think that I'm not practicing basic hygiene just because I'm incapacitated. I am. It's just a few minutes later in the actual day that I'm making this. So just so you know, I want to make that clear. Okay, so how are we going to do these graphs? Well, we're going to graph this on the same axis that we've used for supply and demand, so it's going to be price and quantity. Now again, if you took AP Macro, you know how just anal retentive they are about the graphs and the titles and all that. That's not nearly as important as long as you have price and quantity on the axis. Now we're going to use the exact same concepts that you have saw in the videos and that you did the book work on. So it's the same concepts. Now I don't want to say that you're not going to do the tricky math. You will, and we're going to do more tricky math probably next week. I probably will change my shirt by then. I don't know if I'm going to get to those videos today. But these graphs are going to be like the, I think this is the bulk of this subject. I feel like knowing how to do these. So let's go slow on this. And again, I don't know if you've been repeating these videos or if it's worth it, but again, I'm assuming you're kind of going to know this. Okay, so we're going back to the bottled water episode. You bought bottled water. You bought it at Costco. You paid $1 a piece. I know that's high, but just go with it. You came up with this great idea to go to like a parade or some hot weather activity and people are dying for water, so you're more than happy to sell the bottled water to them. I guess for now, let's say you're getting $2. No, let's make it 3, sorry. $3, that way it's $2 in profit, or so you might think. So we are saying that you are buying the bottle for $1 and then you are selling them for 3. Now, if you remember the example we did the other day, we also said that you bought a sign for $20. It said bottled water here. Now that's a fixed cost. That's the only fixed cost we really had. We just talked about that $20 sign. What does the graph of AFC look like? Obviously the graph of fixed cost would just be a straight line. It's $20. What happens to average fixed cost? Well, remember, average is the quantity. It's how many bottles you sell. So if you sell 1 bottle of water, it'd be the $20 sign divided by 1. 20 divided by 1 is 20. Okay, so AFC would be 20. Now, what if you sold a second bottle of water? Hopefully it's okay, I'm not putting a card up. This is easy, so I'll talk slower. What if you sold 2 bottles of water? $20 for the sign divided by the 2 bottles is 10. So AFC went from 20 to 10. Now, let me skip ahead a little bit. Let's say you now sell 5 bottles of water. AFC, we're averaging out the fixed cost, which by the way is 20, by the number of bottles of water that you actually sold, which was 5. 20 divided by 5 is 4. So we've gone from at 1 bottle, it was 20. At 2 bottles, it was 10. And then at 5 bottles, it was 4. So see how I've made like the little points in the graph here in the air. Okay, it's like the magic board here that's invisible. And that's exactly what's happening. Oh, watch this. AFC is going to slope down like that. The more quantity we have, the more we average out those costs over time. Okay? Let me think of a big example. Think about a bridge. You know, they want to build a new bridge over the Detroit River, the Gordie Howe Bridge. That thing's going to cost like $1 billion. What if only 1 car ever goes over it? Then the average fixed cost of that bridge would be $1 billion. So what are we hoping happens? Thousands, hundreds of thousands, millions of cars go over the bridge because that will lower the average fixed cost. Remember that slope on my magic board? Okay, now I've prepared a sheet, so I need to hold it up because I went to the trouble of making this. Here's what AFC looks like in a graph. Notice it slopes down. Okay, sorry, I was doing mirror image before, so it should have been like this. So ignore everything I did before. Here's the slope. You didn't graph that anyway, and you got the numbers, so don't complain. Okay, here we go. There's the graph of AFC. Notice how it is sloping down. Okay, now is AFC valuable to us? Not really, not in graphing, because it just goes down. It's not really an interesting function. What are we doing this for? Because we're trying to find the magic quantity that a firm should produce. Remember, everything's about quantity. And eventually, when we get all these graphs put together, it'll be a certain point on the graph. So it takes a long time to get to where this gets easy. That graph that I just put up there, that's pretty much useless. I can do it on the magic board the right way. I can do it the wrong way on the magic board. I don't know, that just makes sense to me because it's a mirror image. You get it? So that's AFC. So that's how you're going to graph it. Now, what about AVC? Now, AVC is interesting, really interesting, because it includes opportunity costs. That's what makes it interesting. Now, with our bottled water, every bottle of water that you sell is going to be $1. So if you ask an accountant, hey, what's this guy's variable cost? An accountant would say, well, it's $1 for every unit. So the AVC is always $1. Okay, wait a minute, did that math make sense? So if I buy one bottle of water for $1 divided by 1, that's 1. If I buy 2 bottles of water for $2, AVC is still 1. $2 divided by the 2 bottles. Or we're getting nowhere here with this accountant. What if I buy 10 bottles of water? That's $10 divided by 10, that's still 1. So to the accountant who doesn't think about opportunity cost, because he's not an economist, AVC, average variable cost, is just, I'll do it this way, sorry, is just a straight line. It's useless. But this is economics, where we really like to be precise, and we want to talk about opportunity cost. Now let's talk about your opportunity cost if you are going to do this whole bottled water thing. Maybe you have another job. Maybe you have a life. Maybe you get like sunburn when you're there. There are opportunity costs to selling the water, and they get higher and higher. Now, selling 1 or 2 bottles, probably very low. In fact, you may be just using your free time. But you are going to very quickly reach the point where this is taking over your life. You're passing up your job, you're passing up your future. So the opportunity cost grows a lot, and therefore AVC grows a lot. So AVC is going to have a U shape where it starts to get lower because at first you're averaging out that almost negligible opportunity cost over more units. In fact, opportunity cost might even be negative. You have nothing better to do. Then you're going to reach the bottom point, though, and now it really takes over. Okay, hopefully that made sense. Here's the graph. There it is, AVC. And I made this one ATC first, just so you know, and I scratched it out to save paper because I have been burning through some paper. Now, why did I draw it like a V? Good question that I'm not going to answer yet. I said it was a swoosh, yet I wrote it like a V. Hint, on the AP test, you have to show a low point. I learned this at a conference. If you draw a U, you might miss the low point, and they'll mark you down. If you draw a V, it's still right, and you've guaranteed to hit the low point. All right, that's how to graph AVC and AFC. Coming up, video number 2.